To solve the gas law problems, list your givens. In this problem, the original temperature of 62.2 liters of a gas at 150 degrees Celsius, 62.2 liters is our volume, 150 degrees Celsius is our temperature. And we learned that temperature cannot be done in Celsius, it must be converted to Kelvin. And this is done by adding 273. So our temperature is 423 Kelvin. What is the final temperature in degrees Celsius? We will convert at the end. If the new volume of the gas is 2,440 milliliters and the pressure remains constant. Since pressure is constant, you may cross out that term. The reason I have you list your givens is because 62 liters and 2,440 milliliters, the units do not match. In order to turn milliliters to liters, you need to use the fact that for every liter, there are 1,000 milliliters. And you need to divide 2,440 by 1,000 to get 2.44 liters. Our prediction is if the volume decreases to 2.44 liters, the temperature should decrease as well. We can now solve the problem plugging into the formula P1 V1 over T1 equals P2 V2 over T2. And since pressure is constant, we will cross out that term. And we are left with Charles' law. The mnemonic used to remember Charles' law is lazy Charles needs constant pressure to do his homework. Now, it is often difficult to solve for denominators. We need to solve for T2. My hint is, my recommendation, cross-multiply before plugging in the numbers. So you will be left with the formula V1 T2 equals T1 V2. We are solving for T2. So divide both sides by V1. That way T2 is left alone. And you can now solve the problem for T2 by plugging in the numbers. I will erase this so we have some more space. T1 is 423 Kelvin. V2 is 2.44 liters. And V1 is 62.2 liters. Notice how I continue to keep the units in my work, because now I see that liters cancel and my final answer will be in Kelvin. That helps me see that I've done the problem correctly. When you multiply this out, the answer is 16.59. But since there are the fewest number of sig figs in my work is 3, I will round that to 16.6 Kelvin. Since it asked us to do the problem in Celsius, I need to subtract 273 degrees. And my final answer is negative 256 degrees Celsius. So indeed, the temperature did go down from 150 to negative 256.